try to give some basic idea about all these processes. So, first we will start with the oxyacetylene gas welding process. So, oxyacetylene is a gas welding process. So, basically the mixing of the oxygen and acetylene and the different way means in the different proportionate between oxygen and acetylene, they can produce the varieties of the envelope of the flame, and that temperature actually depends temperature of this flame depends on the what ratio we are mixing between the acetylene and oxygen. Let us see that the proportional of the gases that actually decide the nature of the flame. First we look into the natural flame. So, in this case oxygen and acetylene is mixed in such a way that almost 1 to 1, and in this case if we see from the figure the typical nature of the flame that actually produce the some inner cone and outer envelope during the welding process. So, that probably that outer envelope here actually try to protect the heated zone from the little bit heated zone from the outside atmosphere, and inner cone actually supply the try to melt the molten material. So, in this case if you see that welding of the mild steel, welding of the stainless steel, copper, aluminum, all these type of materials can be welded using the simple gas welding processes. And here natural flame in that sense that we assume the proper mixing of the oxygen and acetylene can happens here also, and depending of the nature of the flame the applicability of the to different material process actually can be decided. Second one is that carburizing flame. In this case the proportion of the acetylene in the mixture is higher than that the required to produce the with reference to the neutral flame. So, that means the acetylene part is more in this case and oxygen part is less in this case with reference to the neutral flame. So, definitely it can be assumed that the absence of oxygen that can be say that there may be some unburned acetylene in this case. So, for this case sufficient burning does not occur. So, it can produce the low temperature with respect to the neutral flame, and at the same time it can create some excess carbon can be created. So, typical application of the neutral flame we can see that welding of the iron and steel, and since excess carbon always produce the hard brittle iron carbide. So, if there is a requirement of producing the iron carbide, in that case the use of the carburizing flame is more preferable, but the maximum temperature is lower than that of the neutral flame in this case. And if you look into this figure, the envelope of the flame is like 3 different, it can create the 3 different envelope. So, if you see the inner cone and outer envelope, but here if you see the apart from the inner cone 2 outer envelope also created, and that can be created due to the nature of the mixing ratio between the oxygen and acetylene. So, third one is the oxidizing flame. So, here if you see the oxidizing flame means in this case the oxygen amount will be the more, and that with reference to the neutral flame. So, in this case definitely since oxygen amount is more, so in this case the temperature will be the more with respect to the neutral flame, and here you can see that from the picture we can see also that apart from the inner cone there is a outer envelope, and that outer envelope is basically smaller and narrower as compared to the neutral flame. So, this type of flame is used when there is a high amount of the heat is required, for example, highly conductive metal like copper based metals, and can also be used in case of the zinc based metals. So, this is the very basic types of the gas welding process. Now, we will try to look into the other welding processes, that is called the sheet metal arc welding process. So, it is well known that sheet metal arc welding process, but here we are trying to focus on the some typical characteristics of this welding process. First is that definitely sheet metal arc welding process is most commonly used, and we can see this welding process is used in the definitely in the construction side also. So, first thing we can see that consumable electrode can be used in this case, but if we see precisely look into the electrode, the electrode is coated with some flux. So, purpose of using this coated flux, that actually try to produce the protective gas around the weld, and then it actually helps to protect this molten pool from the atmosphere by creating the outside creating the protective gas, and finally it creates the produce the slag layer of the one slag that is in weight, that is lighter as compared to the molten material, or maybe as compared to the base material. So, that lighter metal becomes on the top surface, and that creates the layer of the slag layer. So, that slag layer also other way, until unless it becomes cooled down, it also against the protects the this molten material during the solidification process. So, in that case it is very much advantageous to use the in the different way. Basically, it is a electrode is basically supplying the extra material, at the same time it is also protecting the weld zone during the welding process, or as well as during the solidification process also. So, if we look into that figure, there is a power supply, and it completes the electrical circuit, and between the workpiece and the electrode it creates the arc, and the arc is basically surrounded by the protective gas, and that protective gas actually creates from the coating over the flux coating over the electrode. And then if you see the solidified metal, over the solidified metal there is a slag layer. So, after finishing the welding process, it is necessary to remove the slag layer. So, these are the very well known and very stable welding process, and we use most of the cases. But here the choice of the electrodes depends, because electrode material is also important factor here, the what type of material we are trying to weld, and what is the choice can be done according to the metallurgical compatibility of the electrode material to the base material. Based on that, we can choose the different types of the electrode material. In simple way, what are the advantage of this process? It is a very simple process, and mostly this process is used manually. It is a very simple portable equipment, and the not very costly equipment as compared to the other welding processes. But if we look into the limitation of this process or disadvantage of this process is that it is a discontinuous process, because the length of the electrode is limited. So, there is a not continuous supply of the electrode. So, once the electrode is length of electrode is over, then it process becomes discontinued, and we have to feed next we need to feed the another electrode, and then we can continue the process. So, that is the one limitation. Second, the weld metal content also the slag inclusion, because it is a during this high temperature phenomena, molten metal may contain some amount of the slag material may also remain within this zone. So, that is also another disadvantage, and because during the welding process it creates the protective gas, and that is that's why it is very difficult to make it as a make the process control. So, in that sense, this process this process is not converted to the automatic process, rather that's why this process is mostly used for the manual process. Second, we will look into the other welding process, that is gas metal arc welding process. So, with reference to that, shielded metal arc welding process, in gas metal arc welding process, here apart from this we can use a continuous supply of the electrode material. So, that electrode is basically the electrode is used is a continuous wire, and that is wounded in the other places, and it is externally or separately it is supplied to the process continuously. So, in that sense it is a very, we can say that it is a continuous process as compared to the shielded metal arc welding process. So, definitely gas metal arc welding process we use the consumable electrode, and in this case we generally not use the flux, but directly we can use the shielding gas here to protect the molten pool. So, shielding gas like argon, helium, carbon dioxide or mixing of argon, oxygen or any other gas mixture is normally used for gas metal arc welding process, but commercially we generally use in gas metal arc welding process for welding of the steels. Normally carbon dioxide can be used because carbon dioxide is cheaper as compared to the other inert type of shielding gas. So, if we look into the process, that it also create the electrical circuit, that the arc is created between the electrode and the workpiece. And here if you see there is a apart from this, along with the supply of the consumable electrode over some drive rolls, at the same times there is a supply of the shielding gas used through the same nozzle. So, that shielding gas actually protect the molten pool thing, and normally copper nozzle is used here, and this wire sometimes use either the electrode wire is either is a solid or solid wire definitely use, and sometimes it is also used in the form of the some coating may be done over the solid wire. So, this process, if we very precisely look into what are the advantages of this process, we can find out that it is a continuous welding process, no interruption like shielded metal arc welding process, and of course, another advantage is that it is not necessary to remove the slag. So, slag after the finishing of the welding process, slag removal is not required. So, that is why in this way this gas metal arc welding process is possibly can be automated as in that automated, and in that sense it is advantageous as compared to the shielded metal arc welding process. But if we look into the disadvantage in general, that it is a definitely expensive as compared to the shielded metal arc welding process, because it is also necessary to drive the electrode material according to the consumption rate, or that should be adjusted to the consumption rate during the welding process. So, in that way the equipment is a little bit expensive as compared to the shielded metal arc welding process. Then we look one of the most widely used welding process, that is submerged arc welding processes. In this case also we use the consumable wire electrode, and but the difference is that shielding is actually provided not by the shielding gas, it is provided by the granules of the flux is used. In this case, if we look into this picture, though like gas metal arc welding process, here also some drive roll is there, and that actually supply the drive roll is basically control the consumable electrode, and but the shielding is happen using the flux granules, and this low, and it produce the low ultraviolet radiation and also fumes as compared to the shielded metal arc welding process. And flux actually acts as the thermal insulator and suitable for the this process is mainly suitable for the very thick material. So, it is a large volume of the welding is required. So, in that case submerged arc welding is a good choice of that. So, submerged arc welding process also developed in that not only the single wire, twin wire, two wires can be used also. So, instead of single wire. So, it is a kind of taking the advantage of the submerged arc welding process, combining these things, that both shielded metal arc welding process. So, using the flux and takes the advantage from the gas metal arc welding process. So, here the is the consumable electrode, but in the form of the wire. And here if you see, similar electrical circuit is produced between the consumable electrode and the workpiece, but the huge flux actually covered the weld zone. So, that is since the flux granules covered the weld zone. So, in this case the efficiency of the process is relatively higher as compared to the arc welding or shielded metal gas metal arc welding or shielded metal arc welding processes. But if we look into that, typical advantages that it is a very high welding rate. So, as compared to the shielded metal arc gas metal arc welding or shielded metal arc welding process, and this process is basically it is possible to do the suitable for the automation, or it can be converted to the automatic system, and high quality weld structure is can be produced, and main advantage is the efficiency of this process is very high as compared to the gas metal arc welding or shielded metal arc welding processes. Or at the same time the very high welding rate can also be done using the twin wire also. Then 2 wires can also be used in this process to get this, to improve the rate of the welding process or material deposition process. And of course, this process is designed or developed specifically for the or suitable specifically for the very when there is a requirement of the very high thickness or large volume of the material, but also having some disadvantages, that weld may contains the as in general other processes also, that it contains the slag inclusion within the weld zone also, and mostly used for the or suitable for the horizontally located plate. So, these are the 2 typical disadvantages of this process.